All right, so if you're just coming in, there's a do now here. And same aim and homework from yesterday. This is like just the second half of the lesson. This is a multiple choice question, so just choose one option that allows us to create the damped harmonic motion function. And this harkens back to our lesson on composition of functions, which we talked about back in September. So try to remember what that means. Okay, so I'm gonna move us into breakout rooms. So you can discuss this question to just confirm with your group members what your answer is, and it'll just be like a minute or two. I'll give us 2 minutes. Oh yeah, we're in breakout rooms now, so I just want you to, yeah. All right, can someone explain what you or your group member said? You can just start talking. I think, but I think Lucas raised his hand first, and then we'll go to Bipper.
Yeah. So our group basically is pretty simple. You could eliminate answers C and D because the function has to be multiplied by the cosine function. So anything that does not have times h of t, which is a cosine function, can be eliminated. And then by that regard, we were able to ascertain that the answer was B, because it's f of g instead of g of f, because if we were to plug in g of f into the equation, it would not equal the ke to the power of negative ct that we normally get with dampened harmonic motion, and that would only be achievable through answer B.
All right, thank you for that. So okay, so Lucas said B. Bipper, you want to speak to that?
Yeah, our group had the same answer as him, basically the same reasoning as well. So we like checked out each answer, and when we looked at B, the way you would do it is whatever g of t is, which is negative ct, c times t, you would plug that into the function f of t in place of the variable t, which will give you k times e raised to negative c times t, and then you would just multiply that by the function h of t, and that gives you the equation for damped harmonic motion.
All right, very nice. So yeah, well explained, guys. Thank you for that. So yeah, I'll confirm that is choice B, and I'll show you the work here. So yeah, as Lucas and Bipper were saying, f of g of t, that'll get you k times e to the negative ct. So just recognize that g of t is going to be treated as the independent variable, and then that gets plugged into f, right, as they were saying, right? And then as Lucas was saying, we multiply by the cosine omega t function, right? Because we don't want to plug in anything here, so it has to be multiplied by h of t. Okay, so our final answer is choice B. And then the other answers here that I have listed, yeah, those are the other choices worked out. So this is why A, C, or D doesn't work. Okay, and as you can see, it doesn't come out to the damped harmonic motion formula that we want. Okay. All right, so with that being said, for the rest of class, I wanted to go over the classwork. So if I could get a volunteer to present their work for question 1. Okay. So yeah, I think Lucas already spoke, but if there's any volunteers, but if not, we'll go to Lucas also. Yeah. But does anyone else want to speak today? Okay, we'll start with Lucas. All right, and then we'll go to Jocelyn. Okay. All right.
So to present it, what?
Oh yeah, I'm gonna share my screen for the Google Classroom. Okay. All right.
Right. So basically, what the question is asking is for us to find two different equations of damped harmonic motion. They're relatively the same, as in they have the same damping constant, but the difference is, at least in the word problem, one is oscillating at 0.5 cycles per second, and the other one is oscillating at 2 cycles per second. Cycles per second refers to, we can't measure period in cycles per second because it has to be in radians, but hertz is basically cycles per second. So what we can basically do is find it by doing a series of multiplications. So it would be 2 pi multiplied by 0.5 equals pi, which would get us the, at least for me, the omega, the omega, what stands for omega for the first equation, specifically because in the word problem it says it's oscillating at 0.5 cycles per second. And then for the second equation, we just replace the 0.5 with 2, which multiplying 2 pi by 2 gives us 4 pi. And then if we were to plug it into the equation of y equals ke to the power of negative ct, it's important to know here too that it's going to be a cosine function, because it says in the beginning of the problem that it's an initial maximum displacement of 10 centimeters. So it doesn't start at the 0. So it's going to be a cosine function. And using other parts of the word problem, such as displacement of 10 centimeters, which gets us the amplitude, and the damping constant, we'd be able to get for both functions basically 10e to the power of negative 1x, or t would be, x would replace t, that's what I did, cosine, and then you plug in both pi t or pi x and 4 pi t or 4 pi x.
All right, very nice. Yeah, so yeah, these are the final equations, and I can confirm that they are correct. So, well, you might want to be consistent with the variables. So if you use t, then you can also use t here. But yeah, the 4 pi is correct, and negative 0.1 as the damping constant, and then 10. Okay. And yeah, note also that Lucas used cosine because, as he said, right, the question says it's an initial maximum. So because of that, we start at cosine. Okay.
Wait, isn't t time? So wouldn't that be like, with the cycles? Wait, no. Yeah.
Yeah. Well, I guess, yeah, here it would be more conventional to use t as the variable because we are talking about time, right? There's a time factor here because we're talking about cycles per second. So yeah. But it doesn't matter too much, at least for graphing, right? So if you plug into your calculator variables, yeah, it'll come out the same graph. I did want to correct one thing though. So period is actually measured in time. So I don't remember what exactly you said, but so here it would be measured in seconds. Okay, so it'd be like 2 seconds and half a second. Okay. But yeah, everything else is good. So thank you for that. Does anyone have questions for Lucas?
Wait, quick question. So like when it says C, right, we always replace that with the damping constant.
Yeah, so
Right.
C is the damping constant parameter.
So like will they ever call it something else, or will it always just be called the damping constant? Like, is there any other way they'll like phrase it to confuse us or anything?
No, not from what we'll look at this year. Yeah.
Oh, okay.
They'll call it the damping constant for
All
the
right, thank you.
the questions we'll work with. Yeah. And so I did want to show the graph really quickly. So I think Lucas ended up graphing on the calculator, but I'll show it for here for reference. As you can see in red, yeah, so red is the cosine pi t function, and then cosine 4 pi t is the blue function. And well, actually, Lucas, can you speak to part B? I'm not. Yeah, I think you talked about it, but
Yeah. So basically, what would be affecting here is the second function that has 4 pi. It would oscillate a lot more over a shorter time period. So to put it like in very simple terms, it would shrink, or it would thin, as some people would say, which basically just means that there are more oscillations occurring over the same amount of time as the first function. 4 times as many.
very nice. Yeah. So yeah, the only difference here, as you were saying, is the period, right? 4 pi t oscillates much more frequently, but because the damping constant is the same, -0.1, or C is 0.1, they dampen at the same rate. So if you notice on the graph here, the maximums at red and the maximums at blue occur at the same locations, right? So they're at the same level for every time. Okay.
So say the damping constant was like like it can be a positive number, right?
So the damping constant will always be positive. Yeah. C is
So it's
greater than
always gonna be
0.
positive, right? So like if it was like a larger number, what would happen? Would it like shrink faster like that? I'm like, what would
Yeah.
happen there?
So we can actually like test that if you graph it in your calculator. But yeah, I think for the sake of time, we have 6 minutes left, so I want to get to the questions. But yeah, if you test that out, then you'll see that it does more quickly. Yeah.
all right.
Wait, why can the damping constant be negative? Like when you find it?
That's just a convention. So e to the negative ct, that's the convention. So if c was negative, then that would negate the negative sign, right? But the important thing is that we need the exponential to be decay and not growth. Yeah, that's why we just fix c as positive. So yeah. All right, so I'm gonna move on to question 2. And Jocelyn, were you okay with presenting question 2?
Yeah, sure.
Pull up your work here. Yeah, thanks again, Lucas, for that presentation. If we were in class, I would have everyone clap, but yeah. Maybe you can clap virtually. I think there's the reaction button. Okay. Here it is. Here's question 2. All right, Jocelyn, the floor is yours.
Wait, I'm not sure if it's correct because I didn't know whether to use cosine or sine.
Oh, that's okay. Just explain your thinking process.
Wait, can you move up a little bit because like I did some of my work like right on top of the words. Yeah. Okay, so I just like took the information from the question, and the damping constant is 1.20. Oh, I wrote it wrong. Okay, yeah, I wrote it wrong in my final answer, but the damping constant is 1.25, and then the period, which I found by putting like omega over 2 pi, and then I made it equal to 256, and then omega was 512 pi, and then I simply just oh yeah, and the amplitude is set that the harp was pulled a distance of 0.25 centimeters from its rest position, so I'm assuming that that's the amplitude. So I just put it in, and the answer is wrong here. Like it should be 0.25 negative 1.25 t. I'm not sure if it's cosine or sine, but I put cosine, and then and it's 512 pi t. Yeah. Wait, is it cosine?
Well, I'll ask you guys. What do you guys think? Is it cosine or sine?
It's
You can just talk.
cosine
Yeah.
because the problem says that the string is pulled a distance of 0.25 centimeters from its rest position, and that tells you that well, you know that that's the amplitude, right? So that means the graph has to start either at its maximum or minimum, which means it has to be cosine because the cosine graph started at its maximum or minimum.
All right. Yeah, very nice. Yeah. So yeah, we're told that it's pulled from its rest position. So if it's away from its rest position, that tells you that it's cosine. If it starts at its rest position, like 0, 0, then we know that's sine. Okay. Does anyone else want to speak to the equation? Or like, what did you get? Did yours match Jonathan's answer?
Yeah, matched, except for the C value was negative 1.25.
Yeah, I wrote that wrong. I'm sorry.
Okay, yeah, we wrote that here. Yes, this should be negative 1.25 as she wrote here. But there's something else that's missing that I noticed. Anyone see it?
Oh, the E
Oh
is
my
missing.
gosh,
The
the
E.
E.
Yeah, the exponential. Okay, yeah. So
Looks
just
so
make sure.
empty. Oops, sorry.
That should be e to negative 1.25 t.
Oops.
But yeah, this is correct. And the initial amplitude 0.25 is good. All right, so there's like 1 minute left. So I'm gonna get back to question 2 on the graph. So this is what the graph looks like. Yeah, so notice that it dampens to 0 pretty quickly. By like 3 seconds, right? So, and also like it oscillates really frequently because omega is 512 pi. So the period is really short, right? It's 2 pi over 512 pi. But yeah, that's what the graph would look like, okay, if you have this scaling. All right, really quickly for question 3. So I started this yesterday, but we're gonna finish it here. This is the solution or something like it that you should have. So if you remember from yesterday, we started with this and we related the two amplitudes. So the original and then the amplitude after 30 seconds. And then I divide both sides by k. And then from there, I used laws of exponents. So I just split this up into two exponentials. So e to the negative ct times e to the negative 30c is equal to this. So I did in reverse, right? So like if you have two exponents, you add the powers, right? So negative ct plus negative 30c is the same as this. After that, you can divide by e to the negative ct. So most of the time you don't want to do that because functions could be 0 at some point, but the exponential function can never be 0, right? There's an asymptote at the x-axis, so that's okay to divide. From there, you're going to e to negative 30c equals 1/5. Take the natural log of both sides. Okay, I guess this should be on this side. Oh, no, never mind. Yeah, so yeah, so I did ln of e to the negative 30c, and then ln of e to the negative 30c, if you remember they're inverses of each other, you're going to get negative 30c on the left, and then ln of 1/5. Final step, divide both sides by negative 30, and your final answer should come out to 0.0536 if you round to the nearest 10,000. Okay. This is similar to homework question 45, I believe it is. It's like the tuning fork question. That's the one that's due tonight. Okay. So yeah, it's like pretty much the same exact format of solution. Okay, so you set up two amplitudes and then use laws of exponents and take the natural log of both sides. Okay. All right. So yeah, with that being said, just remember to submit that by 11:59. I changed the deadline from 4 to later. So yeah, just as long as you submit that before midnight, you'll be good to go. And yeah, outside of that, if you have no other questions, you're free to go, and I'll see you all on Monday. Take care.
Have a good weekend.
All right. Thank you, you too.
Have a great weekend.
Mr. Liang, are we going to continue with 20 minutes a day next week?
Well, we're gonna add time, so like next week will be 25 minutes, but I'll send out an announcement on Google Classroom. It'll probably be like instead of 2:20, we'll start at like 2:15.
Okay, sounds good. Thanks.
Yeah, but I'll send out a
I
confirmation.
don't see the homework on Classroom. Like the last homework I have is 26.
Oh
the
yeah,
homework.
so it's the same homework. Yeah, homework number 26. That's the one from last time, but this is like the same lesson, so that's why it's like the same assignment. Yeah, so the newest homework is still homework 26.
So then there's no homework.
There's no new homework for this lesson because this is a continuation of the last one, of the last lesson.
Mr. Liang, I had a question about 44B on the homework. It doesn't really make sense to me.
Okay, pull it up. All right, I'm gonna stop recording, so just give me 1 second.